Hello, Geometry and Honors Geometry. We're going to take a look at our guided practice for lesson 10.4. And we're going to take a look at our theorems first, and then work some problems based on our new theorems. So looking at theorem 10.7, we're going to see an angle that we call an inscribed angle inside of our circle here. And the measure of that angle ADB is going to be half of the measure of arc AB. You can kind of see that AB looks a little fatter than this little skinny angle over here, and that relationship is that arc AB will be twice as big as this angle ADB, or angle ADB is half of the measurement of arc AB. Theorem 10.8 is going to talk about the two angles that you see marked as congruent, angle ADB and angle ACB. We have two inscribed angles here, so let's take a look again at what we're looking at because we have some overlap going on. We have angle ADB, which is marked as congruent to angle ACB, and we're going to know they're congruent because when we have two inscribed angles of a circle that intercept the same arc, they both intercept AB. They open up onto AB. Both of these angles open onto AB, so we know those angles then will be congruent. Theorem 10.9. Theorem 10.9 talks about what happens when we have an angle that is 90 degrees inside of our circle. So the measurement of angle ABC will only be 90 degrees if AC is a diameter of the circle. That will make triangle ABC a right triangle. So no matter where we would put a point on this half of the circle here, and then when we would draw from that point, wherever we put it, here or here or here, I put it at B, if we draw segments from B to the ends of the diameter on those circles, then this angle here will be guaranteed to be a 90-degree angle, and then this triangle that is formed with the diameter will be guaranteed to be a right triangle. Last theorem for this lesson today. This theorem talks about a quadrilateral that is inscribed inside of a circle. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. That would mean that angle D and angle F, when you add them together, are 180 degrees. So we have that showing here. And then that would also mean that angle E and angle G would have to add to 180 degrees because they would also be supplementary. So anytime we see a quadrilateral inscribed inside of a circle, we're going to know those opposite angles are supplementary angles. Okay, now we move into some of our problems that work with these theorems. Guided practice 1, we're asked to figure out the measurement of angle HGF. Well, it's inscribed inside of that circle that you see there, and so we'll know that that angle HGF will have to be half as much as the angle that it intercepts. So half of this arc here, half of this arc of 90 degrees, will give us the angle for HGF. The angle measurement will be 45 degrees. So you take half of the arc to figure out and determine the angle measurement for this inscribed angle. Guided practice 2, we are figuring out what the measurement of this arc is. Well, it's going to be twice as much as this angle that is inscribed inside of the circle. So we're going to take our 38 degrees that's given to us, and we're going to double it, multiply times 2, to get the arc measurement of 76 degrees. So remember, our inscribed angles will be half as much as the arcs they intercept. So we have that in both of these guided practice problems 1 and 2. Guided practice 3. Now we're taking a look at an inscribed angle. I've drawn it in red to have it stand out for you. We want to know what is the measurement of angle ZXW. Okay. Well, to figure out the measurement ZXW, we're going to notice that it intercepts this arc ZW. There's another angle that also intercepts this arc ZW, and that is ZYW, which is marked as 72 degrees. Since both angles ZXW and ZYW intercept this arc ZW, they'll have the same measurement. So with no calculating, we can with assurance say the measurement of ZXW must be 72 degrees. These two angles will be the same because they both intercept this arc ZW. All right, example 4 is going to get you to think about what happens when you use the diameter as part of the triangle that you're going to draw inside of a circle. So all inscribed triangles with the diameter as a hypotenuse will be right triangles when you inscribe them inside of a circle. So this is a half circle here, but it works the same way if I just draw half the circle, or I could have drawn the whole circle as well. But this question was talking about a person who's standing here and their camera is pointing at this statue that spreads from here to here, which will be the diameter of our circle. And it asks, where can you move with your camera that can capture a picture at 90 degrees? Where can you move so you will still capture the entire statue? Well, you can move along this semicircle here, because anywhere along that semicircle, you can draw a right triangle, and that right triangle will have a 90-degree angle wherever you stand so that you can see the entire statue. Moving along now to guided practice 5. So on guided practice 5, we have an inscribed quadrilateral inscribed inside of that circle, and we're asked to find the values of x and y. So we're recalling that we have the theorem that tells us that if you inscribe a quadrilateral inside of your circle, then the opposite angles will be supplementary. That means we can add x plus 82 to get 180. We can solve that equation to arrive at x is 98. We can add y plus 68 to 180 because they're also supplementary angles. And when we solve that equation, we'll find y is equal to 12. The last problem will be similar to guided practice 5. So guided practice 6, again, we have a quadrilateral that is inscribed inside of a circle. And once again, those opposite angles will be supplementary. So we can find out the value of c and x knowing that relationship. So first we can say c plus its opposite angle 2c minus 6. They'll have to add to 180. We solve that equation, and we're going to find out c is 62 once we solve that equation. We'll do the same thing to find the value of x. We'll say these opposite angles here, angles b and angles t, they're supplementary, so those two angles will also add to 180. So 8x plus 10x is 180. We solve that for x, and we arrive at the value of x being 10. All right, that completes our guided practice for lesson 10.4. So now it's time to make sure you have these notes, these guided practice notes, and move on to the completion of your homework for this lesson. And we'll see you next time.